Chapter 11, Section 1, Angle Measures in Polygons. The polygon interior angles theorem says that the sum of the measures of the interior angles of a convex polygon is n minus 2 times 180, where n is the number of sides. The first example asks us to find the value of x in the diagram shown. Looking at this diagram, I know that this shape is a pentagon, which means it has 5 sides and 5 angles. Using the theorem, I can say that 5 minus 2 times 180 will give me the sum of the interior angles. I need this to solve for x because I need to be able to add my 5 angles together and set it equal to something. Now, 5 minus 2 is 3 times 180, which gives you 540. Now, I can add all 5 of my angle measures together and set it equal to 540. So x plus 114 plus 105 plus 102 plus 135 equals 540. Add your whole numbers together. X plus 456 equals 540. Subtract 456 from both sides and you solve for x to be 84 degrees. The corollary to the polygon interior angles theorem says that the measure of each interior angle of a regular polygon is n minus 2 times 180 divided by n. Remember that a regular polygon has all equal sides and all equal angles. So this corollary makes sense because the sum of my angle measures will be divided equally between all of the angles of my regular polygon. The example says the measure of each interior angle of a regular polygon is 165 degrees. How many sides does the polygon have? So in this case, I know that each angle measures 165 degrees. What I do not know is how many sides the polygon has. So I'm going to use the corollary and set it equal to 165. So n minus 2 times 180 divided by n equals 165. I'm going to go ahead and multiply by n on both sides to get rid of the dividing by n. So n minus 2 times 180 equals 165n. Go ahead and distribute your 180. You get 180n minus 360 equals 165n. Now I'm going to go ahead and subtract 165n from both sides and add 360 so that I don't have to deal with negatives. You can go ahead and subtract 180n from both sides. You'll get the same answer in the end. 15n equals 360, and we get n equals 24. So, to answer my question, the polygon would have 24 sides. The polygon exterior angles theorem says that the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. Notice that my polygon has to be convex, but it does not matter how many sides my polygon has. This is true for a triangle, true for a pentagon, true for any convex polygon, one angle at each vertex. This question asks us to find the value of the variable in each diagram. If you notice, for question A, we have a quadrilateral. We have one exterior angle at each vertex, and we know that the sum of those 4 exterior angles should be 360 degrees. So 2y plus 2y plus y equals 360. Go ahead and combine your y's. You get 6y equals 360. Divide by 6 on both sides, and you find that y equals 60. If you look at question B, We are given one exterior angle that measures x degrees. If we look at this polygon, they've told us that it is a regular polygon, meaning that it has all equal sides and all equal angles. If all of my interior angles are congruent, I know that all of my exterior angles are also going to be congruent. So count up how many sides this polygon has. It has 6 sides, which means it's going to have 6 exterior angles, which all measure x. So in this case, I can say that 6x times 6x equals 360. Go ahead and divide by 6 on both sides, and you get x equals 60 as well. The next question says that the sign on a building has a long, narrow, hexagonal shape. 4 of the interior angles measure 140 degrees each. The remaining 2 interior angles at each end of the sign are congruent. What is the measure of each angle? In this case, I know that the shape is a hexagon, which means that for n, I'm going to be plugging in 6. A hexagon has 6 sides. They tell us that 4 of the interior angles measure 140 degrees each, and they want us to find the remaining 2 interior angles. The first thing that I need to find is what the sum of the interior angles of a hexagon should be. So I'm going to use the Polygon interior angles theorem, which would be 6 minus 2 times 180. 6 minus 2 is 4 times 180 tells me that all the interior angles should add up to equal 720. Now I know that 4 of the interior angles measure 140 degrees each. So I'm going to take 4 times 140, and that tells me that the sum of the 4 angles would be 560. Now what I need to do is take 720 and subtract the angles that are already spoken for through my 4 interior angles. So 720 minus 560, and that gives me 160 for the remaining 2 angles. So the sum of the other 2 angles is going to be 160, and they are congruent, so I need to divide 160 by 2. 160 divided by 2 will give me 80 degrees for each of the 2 remaining angles. The next example says that if you are designing a sign for a new building, would it be possible to make a sign that is a regular polygon with each angle having a measure of A, 160 degrees, or B, 115 degrees? For this question, I need to use the corollary to the Polygon interior angles theorem. So set your corollary equal to, for in A, it would be equal to 160. I'm going to go ahead and multiply by n on both sides and distribute my 180 on top. So 180n minus 360 equals 160n. I know that 20n would be equal to 360, and when I divide by 20 on both sides, I get n equals 18. So for question A, the answer would be yes, I could make a polygon that has 18 sides. Now do the same thing for question B. So set your corollary equal to 115. Do the same thing that we did above, and you get 180n minus 360 equals 115n. Go ahead and get all your n's, combine your n's. You get 65n equals 360, and when you divide by 65 on both sides, you get n equals 5.5. Well, I don't know about you, but I have never seen a polygon with 5.5 sides, so the answer for question B would be no. A polygon cannot have 5.5 sides. It has to have a whole number of sides. The assignment for Chapter 11, Section 1 is on page 665, numbers 6 through 38 even, and 63 through 73.